This video is going to cover the Check Your Understanding from Lesson 10.1, which is constructing a confidence interval for a mean. In the last video, I did not explain well enough, actually, probably the best way to find the t-star value looking at Table B. So let's actually look at the first problem, which is a 98% confidence interval based on a random sample of 26 observations. The degrees of freedom is going to be 25 because you subtract 1 from the sample size. So if you actually look at Table B, they have the confidence levels listed down here below. I typically use the calculator to find the t-star value, but this actually makes it pretty easy to find your degrees of freedom. You don't have to calculate the tail probability. You just look at the bottom, and then you find your degrees of freedom, and then the t-star value will be listed there. Remember that the degrees of freedom only have a set number of values in it. So if you have a number or a sample size that's in between two values, then you're actually going to go to the smallest value that it's closest to. You're going to round down to this table. So the degrees of freedom of 25 and 98% confidence interval would be a t-star value of 2.485 from the table. And I'm going to show you actually how to find that on the calculator. And you know what, instead, I think let me actually do that for the second one, which is a 99% confidence interval from an SRS of 84 observations. So the degrees of freedom is 84. And a 99% confidence interval. So if you wanted to find that on the calculator, which you really can go either way. I think some of you will prefer the table and some of you might prefer the calculator. The nice thing about the table is that they have the most common confidence levels listed here, and any value on this table you can use. Even if your sample size is 2,000. If your sample size is 2,000, then you would use the 1,000 for the degrees of freedom. You're rounding down. But anyway, so going back to the problem, it is degrees of freedom of 84 and a 99% confidence interval. So in your calculator, if you're choosing to use it, you're going to go to your distribution list, and then you're going to go to inverse T, which is the fourth option. And then the area, that is actually the area that I was talking about, the tail probability. So for a 99% confidence interval, the area on the ends is 1%, on both ends adds to 1%, or if you cut it in half, that's 0.5%. So that is a decimal is 0.005. And then the degrees of freedom would be 84. So using the calculator, you'd get a critical value of, and you'll write that as a positive, as 2.636, let's say. So this is from using the calculator. Now let's compare that to the value that you would get on the table B. So remember, that was 2.636, a 99% confidence level with degrees of freedom of 84. So what we are using is 80, because that is, if you look at our values, that's the lowest, if we round down, that's the lowest value that we have on our table. And with 99% confidence, it's 2.639. So either value would be acceptable, and you can choose which one you want to use. For question 2, we have a national poll of a random sample of 1,640 adults was carried out by Morning Consult. Each person reported how much they or their significant other spent on their engagement ring. The histogram displays the results. Determine if the conditions for constructing a confidence interval have been met in this context. So I'm just going to go ahead and just reveal that. We have the random condition, states that we have a random sample of 1,640 adults. This meets the 10% condition, and it also meets the normal condition by the central limit theorem. And that's it.